Hey guys, I'm just making this real quick video to show you how to do some stuff with DeltaMath. I'm going to start with the problem type for writing the whole equation, uh, mostly because I want to make sure you understand how to actually type that in once you're done with it. So DeltaMath has this cool feature where I can go ahead and plot the points that I want to in order to help me. So I'm going to use that. So we have a center at 310, a vertex at negative 410, and a covertex at 3,6. And so from that, I can tell my A and B value, right? So this 4 is my B value because it comes from the distance to the covertex, whereas this distance of 7, 7 is my A value because it's the distance to the vertex. I'm going to sneeze. Okay, so yeah, we have that. You could put in the whole hyperbola if you wanted to as well, but I'm not going to because I don't feel that I need to. I want to make a note of which direction the transverse axis is going in. So since this right here was the vertex, and that is to the right or left of center, that means that we're dealing with a horizontal transverse axis. So my x term will go first. I'll plug in the center, my A and B, and I will be good to go. So my center is 310. So I'm going to start with that. So I got to do x minus 3 squared. And then I want it to be divided by my A value. Now, if you press divide immediately, at the slash, you know how the slashes divide on the keyboard, it divides in the exponent. So I'm going to right arrow, or you could just click down here. And then if you press the slash on the keyboard, it'll give you your denominator. And that A value was 7, so I do 7 squared for 49. Again, now you need to either right arrow click or just click on the screen to get your cursor out of the fraction to put your subtraction. And then I can again open parentheses, y minus 10 squared, right arrow, slash 16 for 4 squared equals to 1. And then we're good to go. Okay, so now I'm going to show you a different problem type. So this is finding key features. So, let's say you're just trying to find the center or whatever, you do the opposite of the number next to x first, and then the opposite of the number next to y. So for instance, the center here, this is a little review and to start helping us out, is 3, negative 5. Be careful if the y term is first, that you still put the x first in the center. And we are asked to find the covertices. So that will be based on my b value. And so I'm looking right here. That must mean that b is 2, like the square root of 4. And so I'm going to have to add and subtract that distance of 2 to one of my coordinates here. Now, since this 2 is associated with the x term, I know it's the x value right here that I'm going to have to add or subtract to. That's the easiest way to think about it, I think. Covertices means the b value, so it's the second term. And then if that is associated with x, it's an x. If that is associated with y, like if this right here were a y, then it would go with y. You could think about, I know that the transverse axis is vertical because we start with y, and if the transverse is vertical, that means that my covertices would be horizontal. But I think that that's probably a little more complicated way of thinking about it. So I'm just associating it with the variable it's right next to. So I'm going to add 2 to 3 to give me one covertex at 3, negative 5. Sorry, 5, negative 5. And then the other I'll subtract 2 to give me 1, negative 5. And there we go. I said this in the instructions, but if you get to an asymptote one, you can skip that. You're not, I mean, it's good practice. We've done equations of lines, but you won't be held responsible for that this unit. Okay, let's do this with the foci because this one will come out with a decimal answer. So when I look at this, I'm trying to find the foci. Again, you're going to need to know the center to begin with because when you solve for f, that'll just be a distance from the center. So the center here is -2, 1. And then I need to find f, so I'll do f squared equals to a squared plus b squared. And then remember, why am I doing this? 4 plus 81. Remember that these numbers are already squared. That's already a squared, that's already b squared, so I just need to add them together. F squared equals to 85, which means that f itself is equal to the square root of 85. Now, I'm going to show you how you would find the exact coordinate. You are asked to round to the nearest tenth here, so we'll round after, but just because it's good practice. So again, I need to just know which value of the center I need to add this to and which I need to subtract it to. So the foci will always lie on the transverse axis. So I'm looking to this term right here to see what variable is sitting there. And since this first term has an x in it, I know the transverse axis is horizontal. So I know that I need to be adding f and subtracting f to the x term. And if this had started with y here instead, then, sorry, that kind of looks like a 4, but if it had started with a y here, then I would be adding and subtracting to the y. So if I were to try to find my exact coordinates, I would do -2 plus root 85 for one of them, because that is moving me root 85 units to the right of the center. And then my other one, I'm just going to subtract. So I'm still starting with the initial x value of the center because we're talking about a distance from the center, but then we'll move left by subtracting root 85. And the y value stays the same because I haven't gone up or down at all. And so those would be my exact values. When it comes to rounding to the nearest tenth, like you're asked to here, I'm going to just type it in a calculator real quick. -2 plus root 80. Oh no, I typed that wrong. Okay, so this gives me approximately 7.2, 1, and then that makes the other one -11.2, 1, and there are your coordinates. Okay, and there you go. I think that's most of the main problem types. I mean, you might get asked for, say, vertices instead of covertices, but then you would just be doing it based on the first term. Center is in there. Yeah, so you should be good to go. If you need to rewatch any of this, you can. Again, work with each other, do what you need to do, and be ready to come to class tomorrow with any questions you have.